Today we begin our lecture on the liver, gallbladder, pancreas, and the biliary system. We'll look at the origins of the liver, gallbladder, and pancreas here in a minute, but to just start out with where it is in the human anatomy. This brown line across here represents the body wall, and of course that body wall between your abdominal cavity and your thoracic cavity across here, this would be the diaphragm. That's where you see your diaphragm across here. So it's just right up underneath your diaphragm is where you find your liver outlined in the purple right here. We have on this diagram, this would be considered the left lobe of the liver. This would be the right lobe of the liver here, and it's kind of divided right in there. There's a membrane that extends from that separation, that partition, that extends up to the body wall right here, and that's called the falciform ligament. Falciform ligament right there. It's just a continuation of the body membranes between the body wall and the organs of the body cavity. Falciform ligament. Up underneath if you could see the liver from below, you'd see a couple of other lobes of the liver underneath here. One in the back that kind of extends downward back in there. That's where you'd find the caudate lobe is back there in the back. And there's also one called the quadrate lobe, and I can't very well illustrate those without flipping the liver up this direction. So we won't try to illustrate those in this picture. One of the functions of the liver is to produce bile, and bile is conducted from the fine tissues of the liver through larger and larger passages, kind of like capillaries going into venules and so on. So these bile vessels bring bile together in what we call hepatic ducts. And that bile drains downward to the common bile duct. Most of the time, the common bile duct has sphincter muscles which close and constrict and keep that bile fluid from moving down toward the intestine. And when that's closed up, that bile backs up into the gallbladder. So here's the gallbladder. That's all the gallbladder does for you is store bile that's backed up from the common bile duct. There's a short duct that connects between the gallbladder and the common bile duct right here, up underneath the liver, and it's called the cystic duct, C-Y-S-T-I-C duct. So you have the gallbladder, the cystic duct, connects to the hepatic ducts right here to form the common bile duct. The common bile duct drains down until it joins with the pancreatic ducts. So here's your pancreas here. There's the pancreas, and this is the main pancreatic duct right here. The main pancreatic duct. Those two ducts join together right here and form a little swelling, more or less. It's called the ampulla of Vater, V-A-T-E-R. It's also known as the hepatopancreatic ampulla, the hepatopancreatic ampulla. So those come together right there before those secretions are emptied into the small intestine, and we talked about this the other day with the duodenum. That little bump on the wall of the duodenum is called the duodenal papilla, where the pancreatic and bile secretions enter into the small intestine, right there. In this picture right here, we're going to look at where we have the origin of the liver, gallbladder, and pancreas, and all the bile ducts. The way I've drawn it in here, this is be the head end of the embryo up this direction, and that's the back part of the embryo here. This region of this is digestive system, what we call foregut, and along that foregut, there's a swelling right here. This is going to be your stomach. So there's our stomach, and it's just behind the stomach that we see some expansion of the gut wall. that begins the very early parts of the liver and gallbladder and ventral part of the pancreas. So right out here, we have an outgrowth from the gut wall right there. On the dorsal side, on the other side, we also have an outgrowth there that will form what we call the dorsal pancreas. The dorsal pancreas over on that side. So this side over here, we refer to this outgrowth generally as the hepatic diverticulum. And on this side over here, this outgrowth we refer to as the dorsal pancreas. Dorsal pancreas. So in the images that follow, we'll be looking at the events that occur to bring the liver, gallbladder, and pancreas to their final anatomical positions. It has to move around and change a little bit to get there. This is just a closer look at what we just saw a little later on in development. So we still have our stomach up here. This is the beginning of our intestine. That would be part of the duodenum right through there. This is dorsal pancreas. And on this side, what we called hepatic diverticulum before now has a portion that we're going to identify as the future liver, the gallbladder, and then this portion right here is going to be our ventral pancreas. Now you recall that we had just one opening into the intestine from all of these, where the hepatopancreatic ampulla, or ampulla of Vater, connected to the duodenum. Here we have connections on both sides. So what's going to happen is as this lengthens and enlarges, the liver is going to be moved up more. These tubes connecting through here will lengthen, and this ventral connection will be moved around to the dorsal side. Now as things enlarge, the stomach is getting bigger, the cavity of the stomach is taking up more of a shape like a stomach. The intestine coming down right here, the duodenum. You can see the connection on the dorsal side still, there to the dorsal pancreas. The connection on the other side though, you don't see it here. It's moved around to the back side, and actually that connection, that opening into the intestine will be on the other side of the intestine, right about here. So it's moved down some on the wall and to the back side or dorsal side, the far side of the intestine there. So we still have two openings. We have a dorsal pancreas connection. We have a ventral pancreas and gallbladder connection over here on this side. So here's our ventral pancreas still over here. Our dorsal pancreas here. This is going to be our common bile duct. Right here. And of course we have a gallbladder and liver up there as well. Now in our third image, we have the dorsal pancreas and the ventral pancreas both moved around to the back side of the small intestine here. But they're not connected at the same place right here in this diagram. We have the main pancreatic duct still up here. Let me go ahead and put a dotted line through here for the main pancreatic duct. And we have the duct from the liver and gallbladder up here. Here's your gallbladder. I'll just label that GB, gallbladder, right there. And this is going to be your common bile duct. I'll just label that common bile duct CBD right there. Gallbladder, common bile duct. These are the hepatic ducts up here. Coming in above. So the common hepatic ducts join to the what's called the cystic duct. I don't have room to write that in there, but this part right through here is the cystic duct, joins with the hepatic ducts and forms a common bile duct coming down, goes behind the intestine here and on down behind the dorsal pancreas there, and eventually that connection with the ventral pancreas is seen there, and it joins into the intestine. Eventually, you're going to see this dorsal pancreas duct join with the ventral pancreas duct, so this is going to switch over down here. So you're going to have the main pancreatic duct is going to join with the ventral pancreas and the common bile duct portion, where they all come together right there. Sometimes that main pancreatic duct connection right there, let me say in purple, remains connected to the intestine and it doesn't do a complete switch over. In that case, we call that duct coming from the main pancreatic portion right there, that dorsal pancreas portion there, we call that an accessory pancreatic duct. Accessory pancreatic duct. So we still have part of our dorsal pancreas and ventral pancreas, but now they fuse together to make one pancreas, and that's the way it is in the adult condition. You have one large pancreas. We have this lobe from the dorsal pancreas, we have this lobe from the ventral pancreas come together, and the duct from the dorsal pancreas fuses with what was part of the original hepatic diverticulum, now common bile duct and ventral pancreas portions that come together right here. So that they all come together right there at that hepatopancreatic ampulla or ampulla of Vater. Okay, this is a final look at the ducts of the biliary system. So here's the biliary system. We just need to label all of the passageways in all of this. We have the liver in a dotted line up here, so we know this is liver. And the liver produces bile that comes down through hepatic ducts. Sometimes that last hepatic duct right through here, they refer to as a common hepatic duct. Some bile coming down, and then over here we have our gallbladder. Draining the gallbladder, this duct right here is the cystic duct. Cystic duct, where they come together right here, this forms the common bile duct. So the common bile duct leads on down and eventually empties in with the pancreatic duct. So this is your main pancreatic duct here. So that joins together. This is your old ventral pancreas. It has a duct coming up in there also. But anyway, your main pancreatic duct joins with your ventral pancreatic duct and forms this common space where the common bile duct and all these others come together. That's what we call the ampulla of Vater. Also the hepatopancreatic ampulla. The old connection of the dorsal pancreas right there is usually not active or lost, and we refer to it when it is active as the accessory pancreatic duct. Accessory pancreatic duct. So those are parts of the biliary system. The biliary system.